I'd like to talk about open source software and how to consume that software safely. I really struggled with this, but this is the alternate title of this talk, which is that open source software is great, but it can burn your house down. So we need to be careful about how that can happen and what to do about it. So to kick this off, a little bit about me. I've spent the last 8 years at two DevOps startups. First Puppet, starting back in 2011, and Sonatype from 2014 to present, in a variety of product roles. So I've been a UX designer, software developer, and currently a product owner. So that's kind of my background. And Puppet is known for the infrastructure as code concept, which is the idea that you want to treat your servers like cattle instead of like pets. And Sonatype is known for the software supply chain, which is the idea that the software that comes into your application needs to be of good quality. And if it's not, then that can be a problem. And both of these companies really trace their roots back to open source software. And the reason why open source software is great is because it means we don't have to reinvent the wheel. And it means we could focus on the code that differentiates the value that our products offer in the marketplace. Now, before we talk about the ways that open source software can burn your house down, we need to talk about how open source software gets consumed in your applications today. So usually this is kind of how it looks. If you're a developer, you write code. But you don't only write your own code, you also choose open source components so that you can focus on just the code that brings value to your organization. And that code needs to come from somewhere. And typically, this is going to be from one of several public repositories. And we'll get to these in a little bit. Once you've decided what code you need, you have to make sure that when you download it, it's cached somewhere, so it's always available when you need it. And once you build your application, that application also needs to be cached somewhere along with all those dependencies. So this is kind of how open source software makes its way into our applications. Now we get to talk about the fun stuff. What can go wrong when you take this open source software that someone else has written and ingest it into your application? So the first thing that can happen is that software comes from infrastructure that you don't control. And so if that infrastructure gets infiltrated, then a third-party attacker can inject something that can make its way into your application and compromise that application. And in the case of Homebrew, this occurred in 2018. There was an operations engineer who gained access to Homebrew using their exposed GitHub API tokens in about 30 minutes. And that gave this person access to components that are downloaded 500,000 times per month. So this is a huge, huge problem. The second weakness is that these public repositories can go down at any time because they're on infrastructure that you don't own. And furthermore, the components that exist in those repositories can be unpublished or deleted at any time. And so your application is brittle if it has a very strict dependency on these open source components. And so with NPM, NPM is known for not being an immutable repository, which means that when someone publishes code, it can be taken down. And so this happened a couple of years ago with the LeftPad package, where that package got unpublished by its creator and broke hundreds of websites and applications downstream. A third problem that can occur is typo squatting. Now, open source software works because it's built around a web of trust. And these projects that exist on the web, some have large communities around them, which gives them kind of an aura of trust that maybe less popular projects don't. And this is really powerful, but it's also really dangerous, because if an attacker gains access to a namespace that is widely trusted, then it's easier for them to inject stuff that might go unnoticed for a while, because you're not going to be as stringent when you're consuming, say, Linux. Like you're going to trust that the Linux maintainers know what they're doing. And so it's really kind of important to keep in mind that this can happen. And this happened to PyPy, where the Slovak National Security Office in 2018 discovered 10 malicious PyPy components that had downstream applications that were depending upon them. And so because attackers had compromised these components, they were then able to gain access to those downstream applications. The fourth problem is dependencies. And what I mostly mean by dependencies is transitive dependencies. So your application probably has a list of things that it depends on, but those dependencies can also have dependencies. And this can result in a surface area that is much larger than what you think the open source components you consume actually are. So I'm not going to pick on NPM too much, but NPM is known for the dependency hell situation that they put a lot of applications in, where an application could have hundreds or thousands of dependencies through this transitive structure. And the last issue is that open source software ages, like all software. And it doesn't age like humans do, but it does age in terms of the surface area of vulnerabilities. And so when new vulnerabilities are disclosed, which happens all the time, effectively that software is aging. And to borrow from everyone's favorite example, with Equifax, you end up in a situation where they relied on a stress component, and the stress component had a new vulnerability, and within 3 days of that being disclosed, they were breached. And so just an example of how software ages can result in your attack surface increasing. So I've been kind of a downer for the last few minutes. Open source software is great, and everyone here should continue using it. But it's important to keep in mind these ways that it can set your house on fire, and we need to talk about what to do about that. So that's what I'm going to talk about next. There's 5 things I'm going to talk about today. The first is the importance of picking a trusted source of components. The second is checking for quality issues in those components. The third is caching everything. The fourth is bundling everything together with your application. And the fifth is scanning that bundle regularly. So let's start by talking about the importance of picking a trusted source of components. Now, if you take a few seconds and think about all the languages and ecosystems that you use, chances are each of those ecosystems has a public repository that's the canonical source for everything third-party that exists for that ecosystem in the open source world. So Java has Maven Central, JavaScript has NPM, Python has PyPy, Ruby has RubyGems, .NET has NuGet, and so forth. And this is a great place to start, because in the same way that open source software makes all bugs shallow just by virtue of all the eyes that are on that code, a popular public repository has a lot of people who have a shared vested interest in ensuring the quality of software in that public repository. And so starting from a point of popularity is a good place to start. But obviously, this is not the whole story. The next question is, what happens, or what does it take to get a project published into a public repository? And different repositories take different stances. Some repositories are very stringent, and some are very lax. And so this is the list of criteria required if you're going to put a project into Maven Central. And it's quite an extensive list. If you want to publish something to NPM, it's much more lax. And it really comes down to kind of a difference in how the owners of these repositories think about whether they want to optimize for the ease of publishing or the quality of the applications that depend on what's in that repository. So once a project has made its way into a public repository, the next question is immutability. And if it's possible for someone to delete or unpublish a component that exists in a public repository, then you cannot depend on it being there when you need it. And again, this kind of comes down to a question of, do we want developers to feel like they have the power and the freedom to take down things that they think are bad, or do we want to protect anybody who has consumed something upstream? And so this is a very important distinction to keep in mind. And Maven Central, again, is one that takes the immutable approach, and NPM takes a mutable approach. The next thing to consider is the project credentials and controlling what gets pushed into the repository. So if a public repository supports multi-factor authentication, it'll be more difficult for those credentials to be compromised. And similarly, if there's visibility into transference of those credentials, so if I am tired of maintaining a project and I want someone else to maintain a project, like what happened with EventStream, it's important for the community to know that this happened and to be able to vet whether that new maintainer is worthy of that web of trust that we talked about. So we've gone to the trouble of picking a trusted source of components. But the next thing to check for is the quality of the components that we pull down. And the first thing that probably comes to mind when you think of open source software is licenses. This is lots of fun. And the big thing here is that with strong copyleft licenses, it's possible that if you ingest a dependency that has AGPL, for example, that you will be required to release the source code for your proprietary application. And so this is a really important thing to keep in mind. Another thing to keep in mind is vulnerabilities. And given that there are over 100,000 CVEs that are known, it's important to know which of these apply to your application by means of its dependencies. This is another great measure of quality. A third measure is that the maintainers are able to prove that they are who they say they are. And that the project is able to prove that it is what it says it is. And so signed keys and public cryptography can help here. Another element of quality is popularity, like I alluded to earlier. So if you're Linux, you have a large community around it, if issues do arise, they're going to be dealt with in short order. And so that's a really good thing. Whereas if you are a certain Ethernet driver that I have struggled with recently from Intel, and you're a closed source, and the only source that exists is not well maintained, then this can be a real pain if vulnerabilities arise in that code. The good news is that there's a lot of data out there that helps inform the quality of the components that you consume. And these are just a list of a few databases available for vulnerability data. So this is just one axis of the things I've talked about. But all these are really fundamental to giving the open source community visibility into the quality of what it is that they produce. So we picked a trusted source of components, and we're ensuring the quality of stuff that we're ingesting. The next step is caching. And the reason for caching is that the internet at its core is a bit of a dumpster fire, and things can go offline at any time. And as a result, having a tight coupling to the internet is usually not a great idea. But the same is also true of your build infrastructure. So if you want to be able to deploy stuff and not have to rely on your build infrastructure being up for that to happen, then you need to cache those applications as well. And this has benefits beyond that coupling. There's also performance benefits. So the closer something exists, the faster it is going to be to pull from it. And similarly, because these public repositories are hosted by someone else, they have to pay for the bandwidth and for the hosting. And so the more you're able to cache and offload from their servers, it's a great way to be a good citizen of the web. So the usual way that we solve this problem of caching is through repository managers. And there's kind of a couple ways you can think about repository managers. On the left, you might have repository managers that are single purpose, only Docker. And on the right, you might have repository managers that try to be all things to all people. And then on the top, you might have repository managers that exist in the cloud. And so they have some of the benefits of being hosted and ease of use and adoption. And on the bottom, you have repository managers that are hosted on-prem. And so you get more of those performance availability benefits that we talked about earlier. So the fourth step is to bundle everything your application depends on. And the black box analogy is really the best way to describe why this is useful. You don't have to know why the big concrete box is floating in midair. You just have to know what its inputs and outputs are and how to deploy it. And Docker is kind of a great example of this working well. But the other reason why bundling is so important is that at its core, version strings are a bit of a leaky abstraction. And let me talk about what I mean by this. So in JavaScript, I could say I want the latest version of Express. And so every time I run my build, I could theoretically get a different set of bits. And the same is true if I say I want the latest major version of MongoDB. However, even if I specify a specific version string, like async 2.6.2, there's a chance that the bits I get could be different. Maybe I'm building on a different platform, and I get different bits specific for that platform. Or maybe I'm pulling from a public repository that is mutable. And so it's possible someone could unpublish something upstream, publish a new set of bits with the same version, and I get a different set of bits when I rebuild. But it ends up being an order of magnitude more difficult than I've described because of transitive dependencies. And so just because I've specified the versions of what I want in that first list of dependencies, those dependencies also rely on versions of things, and I don't have as much control over what's pulled in downstream. So your laptop can actually be a super fun site. All that discussion about bundling may not have really explained how this relates to open source quality and why it's important to do. So this is kind of the motivator for why you would want to do this at all. And once you have a bundle of bits that represents the thing that you're deploying to production, and you have confidence that it is, scanning that bundle regularly can give you insight into how your software is aging and degrading over time. So this all kind of comes together. Because software ages like milk, not like wine. So it gets bad as it gets older. And because of this, if you're scanning that bundle regularly, you can plot this and say, in these various measures of quality, I can see that my bundle is degrading. And once it gets above a certain threshold, maybe it's no longer good enough to be in production, and I need to remediate it or fix it. But all that data still has to come from somewhere. And one way you could do this is you could say, I'm going to Google each one of the dependencies in my application. And then I'm going to try and extract the data from Google about what's wrong with my application. And you can do this, but it's a bit like shooting yourself in the foot, so I don't recommend it. So this is why vulnerability streams were invented, is to provide a higher signal-to-noise ratio so that you can subscribe to issues of quality and be able to more easily kind of tie what's new with what's in your application. But even here, it's a little bit more difficult than it should be. And so we actually moved to vulnerability databases, where you can actually search for a specific vulnerability or a specific component and see all the vulnerabilities that tie back to that component. And so this is even better. but it's still manual. You can script it, but then you have to maintain your scripts. And so, like, what do we do? So the holy grail is actually automated research and remediation, where you have tooling that's scanning your bundle regularly, finding issues and alerting you to those issues, and sometimes even telling you how to fix those issues. And this is kind of where you need to be. And the reason for that is that time to remediation is becoming extremely important. I mentioned with Equifax, you have a breach being disclosed, or a vulnerability being disclosed, and within 3 days, a breach. That's a very short amount of time. And that amount of time is getting shorter all the time. So it's really important to keep your time to remediation below kind of the mean time to first breach, and it's a bit of an arms race. In fact, I read a research paper recently where someone used an ML algorithm to scrub Twitter for tweets, and was actually able to discover vulnerabilities with 75% accuracy before they were disclosed on the National Vulnerability Database. So actually, time to remediation really is going to hit below zero with some of these new advances in hardware and machine learning that we're discovering. So this becomes really important, and automated research and remediation is really the only way to stay ahead of this curve. So in the same way that there's a lot of data sources for vulnerability data, there's also a lot of tools built on top of this free and open data that can help you do that scanning and automated research and remediation. And I've listed just a few of them here. And a lot of these are kind of ecosystem specific, but there's a lot of options should you want to put tooling in place to do this research and remediation. So this is actually probably the most important part of the whole talk, where we've talked about a lot of process and about a lot of tools, but we haven't talked about how to tell if your company's doing this right is going to be successful at doing this. Because at the end of the day, it's humans that are the weakest link in any chain, and it's humans that have to be on board for this sort of initiative to be successful. You can't just plop some tools in front of them and expect everything to work the way you want. So how many of you have read this book? Just a few? So the Checklist Manifesto is a fantastic read. It's actually written by a physician who had this insight that the vast majority of problems after surgery can be traced back to a very short list of things that are not done prior to the surgery, things like not washing your hands. And if you give the people present in the operating room that checklist for them to check off, you increase the likelihood that all of those things will be done, and you drastically decrease the risk of complications. And this is a really powerful concept. And it applies obviously to software development, where if there's a small list of things that you can do to improve the quality of your software, and the developers have these, and they're checking them off, you don't have to rely on security or legal to be the bottleneck. You can push some of that decision-making onto the developers, and as a result, improve the quality of the software that you release. But checklists have limitations. The problem with any checklist or any process is that humans have a limited capacity to handle complexity. And so if you have a checklist of 100 items, probably people are going to start ignoring it and revert to their old ways. So checklists really only scale to half a dozen to perhaps a dozen boxes. So this is where, again, we come back to automated research and remediation and using tools to help offload some of this tedious toil that goes into ensuring the quality of your software. And the more that you can automate of those things that inhibit software quality, the more likely it is that you're going to have quality in your applications. So here's another book that I read recently and really liked. And you notice one of the authors is Gene Kim, who was the author of the Phoenix Project. And Accelerate is fantastic because it actually goes a step further than a lot of books and actually proves correlation between practices in highly effective DevOps organizations and the results of those practices. So one thing that they talk about is if you ship your software faster, that is actually positively correlated with the quality of the software you ship. So the faster you ship software, the higher quality your software is going to be. Yeah, and so this is also interesting from a process and tooling standpoint, right? Because a lot of us think about security and governance in terms of slowing you down. And if this is true, then it means that if you're getting slower, then your quality is probably suffering, even if you're implementing the right processes and the right tools to improve quality. The proof lies in your velocity and your ability to move quickly. And so it's a really important thing to keep in mind as you start to bring these new processes and tools online. And something else that several other speakers have alluded to already is that it's really important for the entire company to be bought in. If you have a small pool of developers who care deeply about quality, but no other developers do, or management doesn't, or other business organizations in the company don't care, then it's unlikely that this sort of thing is going to be successful broadly across the organization. So really, everybody needs to be bought in. The executives need to be able to pay for the tools that are needed for the developers, and the developers need to care enough to not circumvent that checklist as they deliver software. And the final book I want to talk briefly about is called The Power of Little Ideas. And it presents this concept of a complementary innovation. And a complementary innovation is one with the innovation itself. Tesla is a great example of this, right? Electric cars have very serious limitations. They charge slowly, they have limited range, the distribution network isn't really there. And so what Tesla did is they said, well, let's introduce this idea of a supercharger network. And a supercharger network is a perfect example of a complementary innovation because it fixes all those problems that we talked about. It enables long road trips with your car. It enables it to be charged quickly. And by releasing the supercharger network, which in isolation might not make a whole lot of sense, makes a huge amount of sense when you think about the larger Tesla ecosystem. And Apple is another company that does this very well. And the last thing I'd say here is that this idea of a complementary innovation applies very well to software quality, where if you're an early stage startup, the most important thing is to achieve product market fit. But if the quality of the product isn't good, then you can still fail. So if you've achieved product market fit and you've achieved quality, those two things combined kind of build off each other and can really prove to be a major point of differentiation in the marketplace. And so you can't just ignore quality because your competitors aren't going to ignore quality. And you have to consider all these things that combined can create a larger whole. So just to review what we've talked about the importance of picking a trusted source components. We're checking for quality issues in the components that we're downloading. We're caching everything, both the open source components as well as our own applications. We're bundling everything that our application requires together. And then we're scanning that bundle regularly. And also, we talked about process and culture and how it's really important to make sure that the entire organization is along for the ride for this all to be successful. And that brings me to the end of my talk. Thank you very much for all of your time. And I love feedback, so feel free to reach out to me on Twitter or even in person here. Thank you.